Hi, my name is Muhammad Farhadi from Active Perception Group at Arizona State University. I want to talk about Argos project. Before that, I want to talk about our group at ASU. Our group is started by Dr. Yejo Yang, who graduated from University of Maryland in 2015 and joined ASU as assistant professor in 2016. Our main focus is computer vision, natural language processing, and computer vision with robotics. From 2 years ago, in a collaboration with Institute of Automated Mobility at Arizona, we are also working on computer vision application in transportation systems. IAM is an umbrella of and consists of several companies and organizations in Arizona who aim to improve the safety of the roads by introducing new technologies. Our main focus is traffic monitoring and also average daily traffic data collection. Also, we consider vehicle to infrastructure application where objects need to be detected on the roads and transferred to nearby vehicles. In collaboration with IAM and also NSF ICOR program, we conduct more than 100 interviews, and we also attended at conferences such as Arizona ITS. And we identified 4 main challenges in US for deploying computer vision systems, which the first one is lack of infrastructure. Most of the intersection roads or location on the roads doesn't have internet or infrastructure for sending back the information collected at the intersection. Also, the installation of cost for current technology is very high. At the same time, the maintenance of the system is complicated. And as most of current technology use cloud computing or third party companies servers for processing images, there is some privacy issues. So we come up with this idea that we need a system that process all images inside the camera at the location uh, and send back the information using a cellular network or a low bandwidth system. Also, because we want to reduce the installation time, we were considering to power these cameras to power by solar panels. So not only we can install these cameras at the intersection, we can install them in any location on the roads. Here you can see an example of our system where object detected on the roads tracked and mapped to the 2D map and GIS format. So what's the behind this technology or behind this camera? So we come up with this idea that most of the state-of-the-art computer vision AI systems try to learn all the domains and reach the best accuracy in all the domains. However, in traffic studies, most of the time the camera are stationary and looking at a specific location. So we don't need to know all these domains. We need just specific information about that location. That objects and that distribution of objects can change. That's obvious. So we come up with a system, an online learning mechanism to train a smaller model at the location to use it for most of the time at the inference time. So in this way, we most of the time using a small model. and when we have a change on the environment, we use a deeper model to update that shallower model, a smaller model, to observe the environment. Moreover, we find out in most of traffic scene, even when there are heavy traffic, most of the region are empty, so we don't need to process them. So we come up with a new solution to just focus on those regions that we have objects. And by combining with previous mechanism, we were able to reduce the computation and inference time significantly. At the same time, because the computation reduced, the energy consumption of the system reduced at the same time, and we were able to run our system using a solar panel. As we are processing images on the site at the location, we just send back some metadata, so we don't need to send back the images. So we can use NB-IoT. Now our camera are equipped with the NB-IoT, and which is a narrow bandwidth for IoT devices, and send back this information to our server. And as images again processed on the device, there are few and almost no security concern and privacy concern. So Argos observe the environment, track the objects, localize the objects on the scene, store them on the server, and then when we need this information for a traffic study, we can replay in the 2D, or if even for a specific event we want to see what happened in the 3D format, we can reconstruct a 3D reconstruction of that event on the environment. So in this way, we can also preserve the privacy of the citizen at that location. We evaluated our system with mounting a GPS on the car, and as you can see that our vision detections is very close to what we have observed by GPS. As I mentioned, as we can reconstruct 2D and also 3D, we can do very complicated studies. For instance, we can study the driving behavior of drivers. At the same time, we can also propagate and broadcast this information to nearby vehicles. And also combining with some information that we have based on the map, we can find out whether people on that intersection, on that location, following the rules or not, and how we can improve it. For presentation and our live demo at ITS, previous times we installed one of our camera at one intersection in Arizona. We showed a live demo using a monitor at ITS. At the same time, we had one example of our camera there. We can also, if it's feasible for Charlotte, we can also install, because the installation is very easy. We just need to mount it, and then the camera automatically calibrate itself to the environment, and then at the same time we can see the live output at the using a mobile device, because it's broadcast on the internet. So we can also install our camera at the conference location outside, or we can install it in Arizona, or we can broadcast our already installed camera at Arizona and show there at the demo day, and at the same time we would bring one actual camera to show the physical and the hardware of our system. Thank you so much for your consideration and for your time.